Hi everyone and welcome to a new Sega Mega Drive game dev tutorial. Today we're going to cover a much requested topic, and that is level collision. In this particular lesson we'll do the level collision for a top-down Zelda-like game. And then in the next lesson we'll build upon that basis and then add some gravity and jumping and do the level collision for a side-scrolling game. You can see the end result of the tutorial on your screen now, and obviously we're using Crusader of Centy, the very first scene in the house, as our example. As a quick aside before we get stuck in, you can see from this footage that the character can actually walk behind the headboard of some of the beds and also just behind a bit of the plants and some of the plants, and I've used the tile priority so that that's possible because it's just using one single background layer. However, that does create a little bit of a problem, especially noticeable when you walk behind the plants, where because it's the whole tile that goes behind the player, it's not just the foliage of the plant that goes in front of the player, but also some of the tiles of the floor too, because it's the whole entire tile. Now this could be fixed easily just using a sprite for that particular bit, but it made me a bit curious to look at the original game and see how that handled it. Rather surprisingly, I noticed that the game doesn't need to handle that problem at all, because the headboard of the bed as well as the top green part of the plant pots, they're just basically a solid collision tile, so you can't even go behind them. For me personally, looking at the whole art style of the game, it looks like you should be able to go behind those trees and maybe squeeze in between the beds and so on, but it's not a big deal, is how they made it. But for our purposes here of testing our collision code and making sure that everything's working okay, I think it's really good to have these little very tight nooks and crannies that we can really try and squeeze our character into. So for that purpose, I think it's a good little test. As usual, I'll include a download link to all the assets we'll be using today in the video description, so feel free to download them if you want to use them. And this is the actual Centy Sprite we're going to be using. I've added a couple of boxes to the sprite here just to make the demonstration more clear. On the outside I've got the outline of the actual sprite itself as it'll be on the hardware, and this green box here is going to represent the actual collision boundaries of the sprite. It's entirely up to you where you place the collision boundary. You could, for example, place it on the whole sprite, and that's what you're going to be doing for a lot of games, but for this particular sprite I think it makes sense to have the collision around about where his feet would be. For the background, for the tile set, I'm literally going to use the entire house, so I'm being very lazy here, so we're going to import the entire house, as you're seeing here, as the tile set in 16 tile. So once we open up 16 tile, we're going to go to tile sets, and then we're going to load in the actual tile set itself. So remember from previous lesson, we do plus, and we go to the area here, we select the tile set we want, and then we click open. There is a limit to how many tiles can be in a tile set. So for example, you couldn't just take a whole Sonic level and use it as a tile set, then pretty much paste the whole thing into the editor, but for a whole screen here for 320 by 224 pixels is okay, it works fine. Back in the editor section, I'm going to first of all rename the layer, because we're actually going to be creating a second layer for the collision. So we're going to use this as the background layer, so just rename that to whatever you want. Next up, we need to tell 16 tile which tile set we're going to use. So obviously we're going to use the one we just created a second ago, the one we just uploaded. Now we're going to change the dimensions of the map itself. So this map is a small one, it's just a single screen, so 320 by 224. And now we're going to take the very lazy option, so you feel free to create your own map here using the elements from the Centy Tileset. But for this example, for me, I'm just simply going to highlight the whole thing and paste the whole thing just as it is in the original game. Fortunately, this background just uses one single palette of 16 colors, so you don't have to worry about that. But we are going to do some priority tiles. So remember from last lesson where we set some tiles as high priority, and those tiles are going to appear in front of the character. Since we covered this in just the previous lesson, I'm not going to spend too much time on it now. I'm going to skip ahead, but if you do need a refresher, please see the previous lesson. Okay, with that out of the way, let's use 16 tile to now create our collision map. First of all, we're going to need to load a new tile set, so repeat the process we did before, and instead of loading the background, we're going to load this other file. As previously, you can find the download link in the video description. So the file is called collision tiles, and then load it up and simply choose 16 by 16 as the tile size. If we take a closer look at this file in Sprite, you'll see that there are 16 blocks of 16 by 16 pixels, and each of them have a different colour. In our collision map, each colour is going to represent a different type of collision tile. So for example, the first colour, the first block, the black, is going to represent just a free tile that the player character can move through freely. The second colour, the red, is going to represent a tile that's purely solid, so the character can't move through that one at all. And for our purposes today, those two colours are going to be enough, but you can of course use the remaining 14 colours for all kinds of different types of tile collisions. For example, you could use the third colour, the third tile, the green, as a kind of a water tile that maybe the player can only walk onto if they have a certain set of equipment, for example swimming equipment or a certain set of boots and so on. And then maybe you could use the fourth as a kind of a tile that you can move through one way but not the other. So for example in Zelda, A Link to the Past, you have some of these cliff tiles where you can jump down but you can't go back up, so you can use it for that purpose. You can of course use more than 16 tiles, but I think for most games that will be more than enough. Okay, back in 16 tile now, go back to the editor and we're going to need to add another layer. So go to the plus sign in the bottom here and create a layer, and I'm going to call it collision. Next we want to exit out of the priority mode and back into the regular tile mode by clicking the icon on the left with the 3 squares. Next we're going to have to tell 16 tile which tile set we want to use with our collision map, and of course we're going to choose the one we just uploaded. Back in the editor section, you'll notice that we can't see the background anymore even if we click it in the layers section, but that's to do with these little eye symbols here. So the collision eye symbol, it normally covers over, it's all black squares, it's going to cover over the background layer, but if we click through these we can see that we can show it again. So if it's just an open eye, it means that you can see whatever's behind it, and if we click this half eye here, you'll see that it becomes transparent. With that done, what I need to do next is select the red tile from the tile set, and then simply paste the red tile wherever I want the map to be a solid collision that the player can't walk through. Skipping ahead again, you can see that I've now covered all the tiles that need to be solid with this red colour, and if we take away the transparency you can see even more clearly here with the red representing the solid tiles and the black the tiles you can walk through. If we now take a look at the layer section again, we can see we have some options. So this box on the right here, it just seems to get rid of the grid, which is not so useful. This one here, I'm not sure what it does to be honest, so it's probably best not to mess about with it. The special option we do need to select for the collision layer is this option here with the 4 little squares. So make sure this is selected for the collision layer because it tells the 16 tile that it's going to be a collision array and not a regular background. After exporting this project, if we go into the Centy BG, we can see that that's just a regular background file as we had before, but if we go to the collision one, we can see it's actually a text file, so it's not a background file at all. Now this is actually going to be our level collision. What 16 tile has done for us is take that graphical representation where we created the red tiles and the black tiles, and it's translated it into a form of data that the Mega Drive can understand. I think it's pretty easy to see what's going on. So wherever there's a 1, that's a solid tile, and a 0 is going to be the tile that the player can walk through. Now of course we're going to have to put this into our program file, into our main.c, and we're going to use this as the basis for our collision. And of course we're going to have to write lots of code around it so that the code actually works as we want it to. Before Yuri Neri created 16 tile, I actually had to write this out by hand for every level I did. So for example with my Castlevania and the Shinobi games, I had to write these out by hand, just look at the map and then look back at this text file and then write out the 1s and the 0s individually one by one. So that was a very time consuming process, and it took a lot of concentration. It's very easy to make a mistake, and so that's one of the reasons I was really happy when Yuri created this 16 tiles. It makes it so much easier, especially for very big levels, not just a single screen like this. Okay, and with the preparation all complete, now's the time to go into our actual programming part. So we're just going to continue from the previous lesson. We're going to use that same file, the project we used last time, which was the Mickey Mouse one where we did the priority. And so go open that file, and now we're going to begin to make changes. First of all, let's clean up our res folder, because in the res folder currently we have lots of different various graphical assets from previous lessons. Remember all of these that we've done over the past few weeks. So what I'm going to do is I'm just going to delete all these. Make sure you don't delete the resource.h or resources.res, just delete all the PNG files that we've been using. Next I'm going to add our background that we just created in 16 tile, and also add our sprite too. I'm also going to need to make changes in resources.res, of course, just to reflect the different files that we're loading into it. And I'm also going to change the names we gave the tile set and the map, and also the name we gave the sprite, because at the moment, for example, the sprite says link_img. So I mean, we was using a link there, but then we've used the Mickey sprite, and now we're going to be using this Centy Sprite. So I'm just going to rename to player_img just to keep it consistent so it's not confusing. And I'm also going to update everything else too. As I said before, while you do have to change the name of the files, because obviously the file names we're using are different, you don't have to change the names we're giving the tile set necessarily, but I just want to change it to be consistent. So change it, instead of village map and village tile set, I'm going to change all that to background tile set and background map and background pal. And a little trick you can do, you can highlight wherever you want to, the part you want to change, do Control Shift and L, and then it will just write those to all of the instances of that word rather than just one at a time, so that's a lot quicker. In main.c we're going to need to make some changes just to reflect the different size of the map than the one we used in the previous lesson. So the map width is now 320, the map height is still 224. The player height has also changed, so whereas the Mickey one was 48 pixels high, this one is just 32 pixels high. Remember that I made some changes to the resources.res file, the names of some of the resources, so I'm going to change those. We changed link sprite to player sprite, so I'm going to change that here. And I'm also going to change some other things just to make it consistent. So if we highlight link, the word link, and Control Shift L and then type player, it's going to change all of these to player, player_image and player_x, player_y, because if I left it as link it might be a bit confusing because it's not a Zelda demo anymore. We'll do the same with the village word, so highlight village and then Control Shift L, then change that to background. And finally we just have to delete the PAL set palette for PAL 1 because we're not using PAL 1 in this example. The background uses PAL 0 and the sprites are using PAL 2, so we're going to use PAL 1 empty. And then if we just save and compile, we should get our little Crusader of Centy house instead of our Mickey Mouse game that we created in the previous lesson. And it looks like it's all working fine, so we can move our Crusader of Centy character around. It looks like the priority tiles are working correctly, and of course this has the camera code already in, but because the screen's small anyway, the camera's not going to scroll, and we will also have the code to prevent the character from going off the screen. What we don't yet have is the level collision, so at the moment the player can walk across the beds, up the wall and so on, so that's what we're going to do now. First of all, we're going to have to take the collision array, which was created by 16 tile, and paste it into our main.c. If we take a closer look at the array code, you'll notice it is very similar to when we create a variable. We have the data type, we have the name of the array, but something we don't have when we create a variable are these open brackets here. Now this 280, this just refers to the total number of data points in the array, and if you count how many ones and zeros there are all together, you'll get 280. So whereas a regular variable can only store one piece of data, an array can store many different pieces of data. Just to illustrate this, let's create an example. So I'm going to put the character's age here. I'm going to create 3 variables with the character ages for the different characters in the Castlevania Symphony of the Night game. I could be wrong here, but if I recall correctly, Alucard was around 400 years old at the time of the game, and he is a half human, half vampire after all. I think Maria was probably around 19, and then Richter Belmont, maybe mid-30s or so. Instead of having 3 separate variables to keep track of this data, I can instead create an array that has all 3 pieces of data in it. Just as with the variables, I first declare what data type it's going to use, and I create a name for the array, and then we do equals and then the open curly brackets, and just next to player ages I can open these square brackets, and remember here I have to put the a number of pieces of data that are going to be in an array. In this case we have 3 pieces of data for the 3 characters' ages. Then when entering the data into the array, I simply put the 3 numbers, each separated by a comma. And finally, as with regular variables, don't forget the semicolon at the very end. I hope that little example helped to solidify in everyone's mind what exactly an array is and how we declare one. But now let's delete that and take another look at our collision array. You'll notice that the code that 16 Tiles created for us makes this a 16-bit array, which means that each of the individual numbers can be anything up to around 65,000. Now this is way over what we need because we've only got an array of zeros and ones at the moment. So let's change this to an 8-bit number instead, which allows us to have numbers from 0 to 255, which is more than enough. And of course, being an 8-bit number rather than a 16-bit number, it only uses half the amount of data too, so it will save ROM space. One other thing to notice is that this is a constant. The array is a constant. You can see at the very beginning, before it says UA, it says CONST, and that's because of course we're not going to be changing any numbers in it. The collision array is going to remain the same, so we don't need to be a variable, we can have it as a constant. And even more importantly, for Mega Drive programming, whenever you make anything a constant rather than a variable, it means it's going to stay on the ROM, it's not going to be loaded into the RAM. Since we only have 64 kilobytes of RAM, that's very important because we don't have so much. Now this is a very small map, but especially for bigger maps, if you try and transfer that array into RAM, it can cause lots of problems. It can overwrite different parts of memory, so whenever you do a collision array, always make it a constant. And if you're at all worried about data access from the ROM being a lot slower than from RAM, then as I was before, then don't worry, I've been reliably informed that actually for the Mega Drive, when it accesses data from the ROM or for the RAM, it's pretty much the same speed, so you don't have to worry about accessing data from the ROM being very slow. The next step is optional, but I just want to give the array a shorter name just to make it look a bit better, so I'm just going to change the name here. We're now going to have to create a few more constants just to help us with our code. The first one is going to be the length of the array. To get this, all you need to do is count how many different values, i.e. the ones and zeros, there are in each line, each horizontal line. So, or you can just get the length of the map divided by 16. So this is going to be very important. We're not going to need it right now, but we're going to use it later on when we do some calculations to do with our collision code. If you want to double check, you can just count how many ones or zeros are in each horizontal line and you'll get the result, which is 20. Although of course this will be different for each different map length. You've probably noticed that I haven't put in the data type yet, and we could make this an 8-bit number since it's under 255, but since we're going to be using lots of different map lengths in the future and something might be over 255, let's just make this a 16-bit number so we don't have to change it later. Next up, we're going to create another constant. This time we're going to use the #define method, and you could use the const method as well. I think I discussed this back in the how to animate sprites lesson, so you can have a look at that lesson again if you can't remember the difference. And just before I do that, I've forgotten that when we declare a constant, normally you don't have to do it this way, but normally as a convention we do all the name of the constant in uppercase letters, just so it's clear in the code which type it is, a variable or a constant. Now what we're going to use this define for, we're going to say which number represents a solid tile. Now we know that we're using 0 for a regular tile you can pass through, and 1's going to be the solid tile, so we're just going to write solid tile in uppercase letters, and then we're going to write the number, which is going to be the number 1. Now just as we did in the how to animate sprites lesson, it's just a way to keep track of which number goes with which type of tile, because if we just put the numbers in, especially we have lots of different types of tiles, for example maybe 2 for a water tile or 3 for a slope, it might get a bit confusing. We don't remember what 1, 2 and 3 are, so if we use this, if we actually define this as a constant using define, we can just have it so we can use the name of the tile rather than using the number directly. If this is a little confusing, don't worry, this would all be very clear once we go on and we write more of our code. Now it's time to leave the array and scroll down a bit, and first of all we want to create a function prototype for our collision function. So just as we do here, we declare static void and then write the name of the function that we're going to create. So let's just call it collision and then do the open and close brackets and then the semicolon, and then we need to go down right to the bottom of the file and we're going to copy and paste that, and that's where we're going to start writing our proper collision code. So this should be written just before int main. Remember, then after that we have the while loop, which is what our game loop is, where the code keeps repeating during our game. And then at the bottom here we have all the functions that we created before for the camera and the controls and so on. So right at the very bottom, that's where we're going to create our collision function. So again, open brackets, and this time we're going to do the open curly brackets as well. And speaking of our main game loop, before I forget, let's just make sure we actually call the function in the main while loop. So maybe in between where it says handle inputs and camera, that's when we're going to call our collision function. The collision code can get quite complicated quite quickly, so I'm going to go through it step by step. And just so we keep track of what's happening with the values here, let's add some debug information that's going to display on the screen. So as we covered this in a previous lesson, in the one on different data types, where we created some like debug numbers that we can display on the screen so we know what's going on inside our game. As in that lesson, we need 3 lines of code for this. The first line of code is going to go at the very top here, and the remaining 2 lines of code are going to have to go into our collision function. So again, if you think I'm going too fast, just have a look back at that lesson and I'm sure it'll be clear. Just an example to make sure that the code is working correctly, I'm going to use our player X values. So the debug information on the screen should keep track of what the player X coordinate, what that value is, and it should display it for us to see. If I now save and compile, it looks like we have the, oops, so the number looks a bit higher. I think I know the problem. Remember the player X value is a fixed 32-bit number, so I'm just going to need to convert that to an integer, to a regular whole number, so that it makes sense. And remember, we did the fixed 32 to int. Again, I covered that in the data types lesson. So if we do that, save and compile again, it should look normal now. Okay, so that's better. So remember, our map is 320 pixels in length, so that should be the maximum. But also recall that where it's taking the X coordinate is from the very top left hand corner of our sprite here, which is where you see that square, so the top left hand corner. So that's why it's only going up to 289, because obviously when the right hand side of the sprite hits the wall, the outer edge of the map, our camera code stops it. So that's why you're only seeing the coordinate, the X coordinate of the upper left hand corner of the sprite here. However, if we're going to start calculating the collision, what we're going to need are the coordinates of the 4 corners of the little green collision square that we drew. What we can do is we can use the player X and player Y coordinates, which of course go from the top left hand corner, and we can calculate how much we need to offset them in order to get the coordinates of each of the corners of our collision box. So all we need to do is count from the left hand side and see how many from the left hand side it is to the left side of the collision box and the right side of the collision box, and then do the same for the top and bottom too. How much is it for how many pixels from the top of our little sprite to the top of the collision box, and how many to the bottom of the collision box. We're going to need to record these figures and keep track of them in our code. So let's go up to the top of main.c again, and I think we should do it just where it says player width and player height. We can do it there. We can do more defines to create these constant values. So let's start with the left hand side of the collision box. You can give it a shorter name if you want. I'm going to go with a very descriptive name, and the number of pixels from the left will be 10. So that's going to be the offset we need to calculate. If I skip ahead a little bit here, you can see now I have all 4 of the values here for the left, right hand side and the top and the bottom of the collision box in relation to the actual sprite itself, the coordinates of the sprite. Now that we've got the offsets, we need to actually calculate the actual position of the sides of the collision box. So we're going to do that in the collision function we created. So we're going to have to create some variables, and let's start again by calculating the coordinates of the x coordinates of the left hand side of the box. I'm going to use the signed 16-bit number for the data type, so that should be fine for us. And again, you can call it whatever you want. I'm going to give it a very long and descriptive name, so for the purposes of clarity and so there's no confusion. And then we're going to need to make the calculation, so we're going to have to use the actual player x coordinate, and then we're going to have to use the offset to calculate where the left hand side of the collision box is on the map. And this is the calculation we need. So we take the player x, we convert it to an integer, so we use the fix32 to int function, and then we add the player collision box left to the offset, and then we'll get the coordinates of the left hand side of the collision box. I've also changed the print function so that it shows this value instead of the player x we were showing before. And if you look here, then it looks about right. So even when it's furthest to the left, it's actually 10 and not 0, because obviously it's adding the 10 offset that we calculated that we need. So that's where the collision box is. That's as far as left as it can go, because of course the camera code, it stops the edge of the actual sprite from going off the screen. With that looking okay, now let's go and create the similar calculations and similar variables for the x coordinates of the right hand side of the collision box and the y coordinates of the top and bottom of the collision box too. So I'm going to skip ahead, and the calculations should look like this. I'm now just going to replace the left hand side of the collision box in the print function with the bottom of the collision box, and just to see if that's working okay. So if we compile, save, compile and reload, we can see that it's saying 31. That's as high as we can go, and that will be the bottom of the green collision box. That's the coordinates there. Again, the camera code is stopping us from going any further up, and we can go all the way down to 223, which is correct too, because it should be 1 above the very bottom of the sprite. So that's looking all good too. I assume that all of these are working fine, so we can move on to the next part of the code. We have already created variables which calculate and store the coordinates, the x and y coordinates of our hitbox of the player collision hitbox. What we now need to do is use that information to see that is each corner, the top left, top right, bottom left and bottom right, is that hitting a hitbox within our collision array within our map? Is it going into a tile which is a 1, which is a solid tile? So if that's the case, then we say we can't move the character. However, if it moves in the direction of a tile with 0, with a free tile, then we can move the character. You will recall that our collision array is 280 characters long, so it has 280 numbers. There are either a 0 or a 1 in our example here. Each entry in our collision array has its own index, so you can access the information. So you can see here I've done a graphical representation of the map. So the first one is a 0, then 1, 2, 3 and so on until it gets to 279. What we need to do now is that we need to find a way to use the information we already have, i.e. the coordinates of our collision box, to try and get the tile index of any particular tile in the array. And once we have that information, we can then see whether it's a 0 or 1, and from that we can see whether we can move or we can't move, or any other behavior you would want in your collision code. The code we have to write to access any piece of data within an array is like this. So for example, if I use the name level_col, the name of our collision array, and put 0, then that will allow us to access the first one in it. And if I put 1, it would access the second in the array, and if I do 2, it access the third in the array, like this, and so on. And just to preview that this works okay, if I take, for example, 279, which will be the final entry in our collision array, and if I just paste it in here, so it's going to be printed on the screen in our little debug information. If I save and compile, you should see that the number, the 280th entry, because remember it starts counting from 0, is actually 1. And if I were to use a different index, for example 84, that would be actually a 0, so that'd be one that we could walk through. While we already have the coordinates of the collision box, the left, right, top and bottom sides in terms of pixels on the screen, we need that information in terms of 16 by 16 tiles, because after all that's what the array uses. The solution to this is actually quite simple. We simply divide all of these by 16. To begin with, let's work out how many tiles the left hand side of the collision box is from the left side of the screen in terms of tiles. So when we start counting at 0, then the first tile, horizontal tile is 0, then 1, 2, 3, all the way to 19. So the calculation is pretty simple. We take the player left collision coordinate we had before and we simply divide it by 16 and store it in this variable we just created. To illustrate this, let's take a look at our map again. If the left hand side of our collision box were to fall into the first column of tiles, then obviously the coordinates of that column, the tiles in the first column, are all 0 in terms of the horizontal coordinates. So remember, in terms of the pixels, which is what we have now, it will be anything from 0 to 15 pixels. And so if you take 0 divided by 16, obviously it equals 0. If you take 15 divided by 16 is 0, because we're using whole numbers, not decimal places, and anything in between will equal 0. And if it falls into the second column, which is column number 1, remember we start counting from 0, then 16 divided by 16 equals 1, and also it's 31 divided by 16. You can only fit 116 there if you're using whole numbers, so that'll work out fine too. Just to show that our calculations are correct, if we take that new variable and put it into our little printed debug information, then save, compile and open the ROM, we should see that instead of, remember this is measuring the left hand side, which tile it's in terms of the horizontal aspect, so it'll start at 0 and go all the way possibly up to 19. So you can see here it's not going up in terms of pixels, it's going up in terms of tiles. Now it only goes up to 18 because we're measuring the left hand side of our collision, our little green collision box, and because the camera code, it stops it from going too far to the right, it can't quite reach 19. Hopefully you remember it when I did the lesson on data types that we try to avoid any multiplication or division functions on the Mega Drive because the CPU isn't so great at handling it. It can do it as we just demonstrated, but it's better to use bit shifts if we can, if we're dividing or multiplying by 2 or 4 or 8 or 16, 32 and so on. To divide by 16, we simply use this notation. We do the 2 arrows to the right and then we bit shift by 4 places. And then if I save and compile and we reload our ROM, we will get the same result as before, which is a division by 16. So we've confirmed to have which column the left hand side of our collision box is in. Remember it starts 0 and the final column is 19, so 0 from 19. Of course that will change depending on the size of your map. We can do the same for the right hand side as well of the collision box. And also of course we can do which row, i.e. what the Y coordinates of the tile the top of the collision box is currently in, and also the bottom of the collision box. And once all 4 are done, it should look like this. Just to make sure our calculations are going okay, I'm just going to replace the debug info with the Y tile coordinates of the bottom of the collision box. After saving and compiling and opening up our ROM, you can see at the moment the debug info says 1 because we're in the second row of our map, and then 3, 4, 5, 6 and all the way down to 13. So that's the bottom row of our map. So remember we're looking at the Y coordinates in terms of the tiles, 16 by 16 tiles, so it goes from 0 to 13 in our map. And I'll just count the rows here just to prove it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And since we begin counting from 0, it means we have 14 rows of 16 by 16 tiles in our map, so 0 to 13. Okay, so we've made progress. Now we have the coordinates in terms of tiles for the left, the right, the top and the bottom of our collision box. And as with any 2D grid, you can use the X and the Y coordinates to calculate exactly where on the map a particular point falls. So we're going to use that to find out in which tile of our collision grid the top left hand corner, the top right hand corner, the bottom left hand corner, the bottom right corner, we're going to calculate where they fall exactly on our map. Let's go ahead and create the first of these variables. So we're going to calculate which index or which tile in terms of the array index the top left hand corner of our collision box falls into. So remember we're taking the top left hand point of our collision box. So if I go back to our map here with the index numbers, if you look at the top left, then at the moment it's falling to 22, where it's falling at the moment, and we can move it. So 22 at the moment, then 23, 24, 25 and so on. So as it moves around the map, we want to get this the index number in terms of our grid of the top left hand side. I will show you the mathematical formula we use to calculate this first, and then we'll go through a few concrete examples just to solidify it in your head. Since we're calculating the top left hand corner of the box, we're obviously going to need the coordinates in terms of tiles in the x coordinates of the left hand side of our collision box, and also the y coordinates of the top of our collision box in terms of tiles. We are also going to use a constant value we created earlier, and that is the horizontal length of our array. So we're going to need that too, and in the end we will end up with this formula. So we take the y coordinates of the top of the collision box, we multiply that by the length of the horizontal width of the array, and then we add the x coordinates on top of that. Just to make sure that everyone fully understands what's going on here, let's take a look at a couple of examples. So here we've got the top left hand side in the 20th position of our array. So make sure let's use our formula, make sure we get the number 20 from using it. You can see that the top left hand corner falls into the column number 0 and also row number 1. So you can think of those as the x and the y coordinates respectively. If we were to put these numbers into our formula, we will get 0 plus open brackets 1 times 20. You don't need to be a math genius to calculate that 1 times 20 equals 20 and plus 0 it just equals 20, which is exactly what we had on our grid. Let's do one more example. So if for example the top left hand corner were to fall into this tile of our collision grid, this would be index number 122. As with last time, we need to get the x and the y coordinates in terms of tiles, or you can think of it as in terms of columns and rows, and you can see that is from the left hand side, the horizontal one is 0, 1, 2, so risk column number 2, and from the top, if we count from the top beginning from 0, we will get the number 6. So if we do 6 times 20 plus 2, maths is a bit more difficult in this one but not too hard, we will get 122, which is exactly what we wanted. I hope this shows that we can use this mathematical formula to get the position of any point on our map, whether using the top left hand corner or the other 3 corners. So that's what we're going to do now. We're going to do the same for the other 3 corners of our collision box. And the end result should look like this. So from these 4 variables you should be able to get the index of the top left, top right, bottom left, bottom right of our collision box, which tile on the grid they're falling into. Now let's do a quick test. Let's, in our little debug box here, let's put the index of the array index of the top left hand side of our collision box, and let's see if it's working. And as we move our character around, you should see that the top left hand side of our green collision box is falling pretty much where you'd expect it to. So we have the index numbers of the array here, so we can keep moving it around, and that's looking just about right. The next thing we want to know is which kind of collision tile is at these 4 different indexes. So is it going to be a 1, a solid, or is it going to be a 0 that we can walk through? As always, we're going to create some new variables for this. So first of all, let's try and get the information of what the array index of the top left hand corner of our collision box. We want to know what kind of collision tile is that. Is it a 1 or a 0? Again, for clarity purposes, I'm going to give mine a very long descriptive name, so I'm going to call it tile collision type top left. Let's head up to the top of the file and take another look at our collision array. So we're going to take whatever you call the collision array, the name of it. So in my case is level underscore col, and paste that here, and then open these square brackets and then a semicolon. Now what we put inside of the square brackets is obviously going to be the index number of the tile in the array that we want to get the information from, so the 0 or the 1. Since we're doing the top left hand corner, we'll put the array index top left col box variable into that, and then we're going to put the tile collision type top left into our little debug information. And now let's go and see what it looks like inside our ROM. So as I move around the map here, you should keep your focus on the top left hand corner of that little green collision box. So we should see that when it's on the floor it should be 0, and as we get close to either one of the beds or the furniture or the wall, it should change to a 1. So remember, it's the top left hand side of the collision box we're looking at here. So we just move into the table there, or if we move to the plant pots, we can see it change to 1. If we move up into the bed, it changes to a 1, and the rest of the time when it's just on the floor, it should be a 0. So you can see it's working as we expected it to. We can go in between the beds here and it's a 0, but if we move on to the bed, it turns into a 1 again. So we can now go ahead and do the same for the other 3 corners of our collision box too. And repeating the same process, the resulting code should look like this. It'll probably be a good idea just to test each and every one of these variables just to make sure it's working okay, but for the sake of brevity, I'll just check the collision type of the bottom right or corner of our collision box and just make sure that's working okay. So again, save compile, open up our ROM and just see how it looks. So what we want to focus on this time is the bottom right hand corner of our little green collision box, and we want to make sure that when it lands on a floor tile like a regular floors, it should be 0, and as soon as it hits any kind of object or collision object or the wall, it should result in a 1. So it looks like it's working fine now, and we would assume that it's working fine for the other 2 corners too. So now, after all that considerable time and effort, we finally know when our collision box is falling in a solid tile or a free tile, and now we can use that information to adjust our movement code so that the player only moves when they're allowed to move. At the moment, all that movement code is within our handle input function, but we're going to change that, and in order to do so, we're going to create some what are called booleans, which I'm not sure if I've covered yet in these tutorials, but it's basically a variable that can either be true or false. So we want to see whether the character's moving to the left, to the right, or up and down, and we're going to start with the movement to the left. The way we create these variables are the same as when we do a regular variable. So we're going to first let it know the data type, so it's going to be a boolean, and the code for that is BOOL, and then we're going to give it a name. So we can, for example, move left or move player left or whatever you want, and then finally we make it equal to either true or false. Okay, with that done, now we're going to go back to our handle input function. Now at the moment, when you, for example, you hit the left D-pad, then the character's going to move to the left, and we covered all this in a previous lesson on D-pad controls. So we're going to comment out that line, and instead of moving it to the left, first we're going to say, okay, is the player moving to left? We're going to make that boolean true. We also need to create some circumstances where that boolean is going to be false when the player's not moving to the left. So obviously, if the D-pad's being pushed to the right, then they're not going to be going to the left. So under that section, let's make player move left equals false. And then finally, we're going to add an else statement. So we have if buttons, if the D-pad's moved to the left, do this. If it's to the right, do this. Or else if neither of these are pushed. So if the player lets go of the left D-pad button, then that means that we also don't want the player to continue moving to the left. So we're going to make that false in that circumstance too. If you were to save and compile at this point, you should notice that you can't actually move to the left anymore because we don't have any left movement in our code. So you can move up and down and to the right, but we can't move to the left at all. Of course, we do want to be able to move to the left sometimes, but only when it's a free tile. But to begin with, let's just restore to where we were before. So in the collision function, we're going to create an if statement that if the player move left boolean is true, then we're going to move the player to the left, just as we did in our handle input function before. And if we now save and compile, we should be able to move left just as we did before. Now the next step is to start to change that code so that we're not going to be able to move on to the beds or any other object which is solid. Let's head back to our map and we'll see how this is going to work in theory before we actually write the code. We're first going to let our character move as normal into the square, and then we're going to use our calculations that we've already done to see whether either the top left or the bottom left is actually falling into a solid square. And if it is falling into a solid square, then we need to move it back so that the left side of the collision box is just on the edge of that solid tile. Since this is all taking place within a single frame, you're not actually going to see any kind of pushback in the game. It'll happen within the same frame, so you're not going to see the player be pushed back. If the player does move on to a solid tile, then the problem we're going to have to solve is to calculate the new coordinates, the x coordinates of the player sprite, what they should be. Remember that we calculated before the column number, or the how far from the left in terms of tiles. So remember, we begin to count from 0, so the first column is 0, 1 and 2. And 2 is what our character sprite falls into now. Now if we take that number 2 and we times it by the size of each tile, that'll be 16, then we'll be like this. So this is 0 at the moment, this is 16, and then this is 32. So 2 times 16 is 32, because remember, when we use the player X, it's actually doing it from the pink square, from the left hand side of the pink square, which is actually our player coordinates. So what we need to do is we need to add 16 to that number, and then we'll get this position. But of course we're still too far to the right, so we need to minus the offset that we calculated at the very beginning. Remember the distance from the edge of the sprite to the left hand side of the collision box, and if we do that, then we'll then get the perfect coordinates of where player X should be. Okay, now we got the theory out of the way, let's head back to main.c and write some code to actually make that happen. Firstly, I'm going to take some of the calculations we've made already and I'm going to move them into our if player move left bit of logic. We may need to use some of these variables in various parts of our code, so I'm going to leave the actual definition of the variables where they are, but I'm going to do the calculations within the if statement. So if we copy here, we can so this is the statement, so it's still the compiler still knows that this variable exists, but we're doing the actual calculation within the only if the player move left is activated. And I'm going to do the same for anything we need for the left hand collision, the left side collision. I'm basically going to make sure the calculations are done within the if statements, and I'm of course going to leave the definitions of the variables where they are. Not only is this easy on the CPU, because after all there's no point doing some collision calculations if the player isn't moving like to the left or to the right. It's also going to be important when we start to add some other things into our collision code too, so it's best that we do this now. I won't skip ahead on this part, I'll let it play out as I do it in real time just to make sure that no one gets lost. So as soon as it's done, there's a few more copies and pastes and adjustments, then we'll be done. Okay, so now we've already transferred all the calculations necessary to see whether the top left hand corner of the collision box is moving into a solid tile or a free tile. We'll do the same for the bottom left of the collision box a bit later, but for now let's create another variable. So we're going to create this variable that's going to store the X coordinates of the player if they were to fall into a solid tile and need to be pushed back again, just as we described when we looked at the map just a moment ago. I'm calling mine blocked left coordinates here, but you can say, pushback coordinates or whatever name you like to give it. So now we're going to calculate this value. So the formula is just going to be as we said when we looked at the map earlier, and just before I write the formula, I'm going to copy and paste this into our little debug info so we can see what's happening on the screen in terms of the numbers. Remember that we're going to take the X coordinates of the player and of the collision box in terms of the number of tiles, or you can think of it as the column number, and we're going to multiply that by 16. And of course, whenever we're multiplying by 16, we can use a bit shift. So remember, because we're multiplying, make sure that the two arrows are pointing to the left, and then we move it 4 spaces. And of course we're going to add 16 too, because that's the tile size. Remember, if we didn't add 16, then it was a bit too much to the left. I'm now going to cut that particular formula because we're going to put it inside an if statement, because remember, we only have to do this calculation if the top left hand side of the collision box is falling inside a solid tile. So we can create an if statement, and in it we're going to put whether the type of collision, as in the top left, that the top left of the collision box is falling into, whether it's a solid tile. And remember, earlier in the lesson we made the solid tile equal to 1, as you can see up here. Our if statement is going to require some curly brackets, so let's write them now, and we're going to paste the formula that we had before. If we do want to stop a player from moving into the solid tile, of course we're going to have to change player X. So we already moved player X previously to take into account the D-pad direction, but now we're going to say, okay, it's been moving into a block tile, so let's move it now to the edge of the block tile and not let it move inside. So remember, player X is actually a fixed 32 number, whereas our little calculation here for the coordinates it should be if they get stopped from moving into the block tile is an integer. So we're going to have to make player x equals to the block left called variable, but we're going to have to use this little conversion to convert it from an integer into a fixed 32. Okay, now let's save and compile and see what the ROM looks like. Okay, so we are getting collision and that's good news, but you can see that the player's been being pushed back away from the collision a bit too far, and that's because we've missed out one little thing in our calculation we did earlier. I think you can look in, you can probably guess what's happening here. So when the collision box of the player is colliding, the left hand side is colliding with the solid tile when it's moving left. The player's been pushed back, which is great, which is what we want, but it's being pushed back to the edge so that the edge of our actual sprite is lining up with the edge of that solid tile. Remember, we have an offset where we need to move it so not that the left hand side of our sprite moves against the solid tile, but the left hand side of our collision box moves in with the side of that solid tile. So if we simply subtract the player collision box left, the little offset we did before, and then save and compile and reload, that problem should be fixed. And now it's all working as it should. So even though I'm keeping hold of the left D-pad, it's always getting stopped by either the bed or the wall or flower pot or anything else in the scene, any other solid tile. And because we got the figures correct, the offset, everything correct, you're not seeing any pushback, everything's happening within the same frame. So the top left hand side of the corner moves into the solid tile and it gets pushed out, but it's happening in the same frame, so you don't see anything happening. So we've got that for the top left hand corner of the collision box, but now we have to do it for the bottom left hand corner, because at the moment if the bottom left collides with any solid tile, it can move through it quite easily, and we need to stop that. Thankfully, all we have to do to make this work is to repeat the process we did with the top left hand corner. So any of the calculations above to do with that we need to calculate whether the bottom left hand corner is falling into a solid tile or a free tile, we're going to take those and we're going to do a bit of cutting and pasting and copying, and we're going to put that into the if player move left statement. I will let this play out, I won't skip forward just in case anyone gets lost on the process, and as soon as it's done I'll be back with you. Okay, so thankfully we only had to move a couple there, and now we can move back to our if statement. So rather than just make it that if the top left hand corner of the collision box, if that falls into a solid tile, then we should be pushed the player back. We need to make it if either the top left or the bottom left moves into a solid tile, then we get pushed back. So remember, we use this two upright lines to use the OR logical symbol, and with that done we can save, compile and see how it looks. As I just freely move around the map here, you'll see that whenever I'm moving to the left hand side, if either the top left or the bottom left of the little green collision box collides with anything, then it's going to stop us moving to the left. Now obviously if we move up, down or right, that doesn't apply because we don't have any collision code for those directions yet, but for moving to the left it's all working fine. If we were to have a taller sprite, then we might need to take a third point, for example in the middle of the sprite, to make sure that the center of the sprite didn't move through any particular solid tile. But since our sprite's very small here, just taking the top left and bottom left corner will be fine. I'm sure you'll all be glad to know that we're now pretty much in the home stretch of our code here, because we've already done it so that the left hand side, the collision one moving to the left is fine. Now we simply have to do the same for the moving up, moving down and moving to the right. However, don't worry, I won't rush through this, I'll go through this nice and slowly. The first thing I want to do though is to comment out this the debug info, because we seem to be bugging out. If anyone knows a reason, let me know, but I don't think we need that anymore anyway, so for now I'll just simply comment it out. With that little thing out of the way, let's move on to the collision when moving to the right. So first of all, we need to create just as we did with the left hand side, we need to create a boolean, a variable to say, okay, is the player moving to the right or not? We can now move back to the bottom to the collision function, and just as we had before, the if player move left statement, we can add an else if to that, and if the player is moving to the right instead. And then right out we do the open brackets, and we'll put the right hand collision code in that in a moment. Next we have to go to the handle input function, because remember we have to make it so that the player doesn't automatically move to the right whenever you hit the right on the D-pad. We need to instead change the boolean value to either true or false, just as we did with the left hand side, and any player movement is going to take place within our collision function instead. So if the player is pushing the D-pad button to the left, we're going to make the player move right boolean false. Obviously if they're moving to the right, we make it true, and if there's neither been pushed to the left or the right, we're going to make it the player move right boolean false. We shall now head back down to our collision function, and within player move right, first of all we're actually going to put the player movement in here. So first we're going to move the player according to the instructions on the D-pad, and then after that we're going to do the calculations to see if that then moves the right hand side of the player into any kind of solid tile, and if it does, then we're going to push it back like last time. And just as with the left hand side, the left hand movement, we're going to one by one just take some of the any calculations we need to calculate this. We're going to move these into the if statements, while keeping the actual definitions of the variables up at the top of the collision function. With that done, we can now go ahead and create our if statement. So just like last time, we're going to say if the tile type of the top right this time is equal to a solid tile, or if the tile collision type for the bottom right is equal to a solid tile, then what we're going to do is we're going to push the sprite back a bit to the left, so that the right hand side of the collision box is right bumping up against the left hand side of the solid tile that it's walking into. After adding the curly braces for the if statement, the next thing we have to do, of course, is calculate what should be the x coordinates of the player in the case that it does get pushed back from a solid tile. We could probably just reuse this variable, but I'll create a separate variable for the right hand side here just to keep things clear. So we're then going to calculate what this should be, and if you remember when we looked at the map before, if we're calculating the collision when it's moving right on the horizontal axis, we don't have to add the 16 like we did for the left hand side. We just simply have to multiply the column number or the x coordinates in terms of tiles by 16, and then we have to minus the offset for the right hand side of the sprite, the collision offset. And that will be this one here that we defined before. We will now make player X equal to that block coordinate we just calculated, if in the case it does straight onto a solid tile and save and compile, and let's take a look. So playing about with it here, it's actually being blocked on the right hand side now, so I can't move into this table. We're getting the proper pushback, so everything's looking smooth, and it looks like we've already got the left hand side done and the right hand side's working too, both the top and the left corner. There's going to be some kind of glitchiness because obviously we haven't done it for up or down yet, so if you move up into like a solid tile or down and then try and push left or right, there's a bit of a strange effect, but that's no worry. We'll now do the top and the bottom collision, and then that should be sorted. First of all, just as with the left right, we're going to take the movement code and move it out of our handle input function and into the collision function. We're going to create the booleans for up and down too, so I just do that right now. Now let's go back to our collision function just underneath left and right, and we're going to use two if statements, this time if the player is moving up or down. And just as with left and right, we're going to put the movement code in here. So first we're going to move the character either up or down, and then we're going to see whether, do the calculations to see whether the tile they've moved into, the collision box, is a solid or is a tile they can move through. If it's a solid tile, then we're going to push them just out of that tile, and we need to calculate the coordinates of that they need to be, the new coordinates. You can see that at the moment we still have these four particular variables where we actually calculate them before we go into the if-else statements, and we're actually going to leave them where they are, but we're also going to do those calculations again when we in the move up and move down if-else statements, depending on whether we need the top or the bottom. The reason for that is that obviously moving left and right, they also need to know where the y coordinate is. So you either calculate the collision via left or right first, or up or down first. So we're choosing to do left and right first, and they're going to need some y coordinates, and so they're going to be using the old y coordinates, and we're going to be updating them when they move up and down. So you have to choose to do one first and one later. It's normally best to do left and right, the horizontal collision first, because it makes it easier in future when we eventually do stuff like slopes and other more complicated collision tiles. So for the player move up movement, we need to calculate the top left and the top right hand corner of our little collision box. So actually the good news here is that we've already done those calculations within the move left and move right if statements. So we can just copy and paste the code we need from there, and I'll just show you what the finished product should look like. So here I've already copied the relevant code from the left and right if statements, and we have the tile collision type for both the top left and top right. So now we can move on and do the actual movement code. Let's do the usual if statement. So if the tile collision type, and let's just start off the top left to begin with, if that equals a solid tile, then we're going to do our blocked coordinates. So if it does move on to a solid tile, then where do we need to shift the player to? And then we'll make player X equal to that coordinate. Actually, before I do so, let me just clean up our little blocked, because at the moment we've got blocked right coordinate, blocked left coordinate. We could have an up and down one too, but I think we can just use one single variable for this. So I'm going to change all these just to a single variable, which will be blocked underscore COORD, and we're going to use this in all cases. And it doesn't matter, we only use it temporarily, and then we make player X equal to that. So Obviously we're going to use it for either left or right, and then we can overwrite it. It doesn't matter once we do it to up and down. And I'm deleting the spare one, again changing the original definition to block_chord, and then we're going to use that in our up and down ones as well as our left and right. While we don't need to do that, it just makes our code look a little neater. The block coordinate calculations pretty much the same as we did with when we did the thing for the left hand side. So remember, we're going to take the row number this time, or you can say the vertical coordinates in terms of tiles, and then we're going to multiply it by 16. We're going to add 16, and then we're going to deal with the offset of the player in terms of where the collision box is in terms of the actual sprite itself. And after this, we simply make the player y value equal to this variable, and of course we have to, since it's an integer, we have to do the integer to thick32 conversion as well. Before we save and compile, I'm just going up to the top here and change the player X and player Y. So this would be the coordinates the player starts off in, just so the player appears in the middle of the map rather than at the edge, otherwise we could get stuck on some kind of collision. After saving and compiling, we can see that it's working okay now. So the top left hand corner, when it moves up, it collides as we want it to, but of course the top right hand corner doesn't at the moment. So let's go back to our code and just add that. And just like last time, we're going to do if either the top left or the top right hand corner is colliding with a solid tile, then we'll carry out the code within the if statement. And again, if the player sprite happens to be quite wide, then we might need a third coordinate at the top, maybe in between these two coordinates. But since our sprite is so small, that should work fine. And after saving and compiling it yet again, you can see that now both the top right and the top left are having the correct collision. So if I try and walk up through this table, I can only move up once I pass the edges of the table, either on the left or the right hand side of our collision box. Now I'm just testing the code. I'm trying to get into these little nooks and crannies, because especially with these small spaces, if there are any bugs in our code, then this is where they'll show up. So you can see I can squeeze into those smaller spaces, but if I hold the top right of the D-pad and go across, you can see there that there's a little problem where it looks like it's about to go into that little hole, but then it stops. And if you move over to the right hand side of the right wall here, and try to undo the same, hold right and up at the same time, the directional on the D-pad, you can see that it gets stuck. And for those of you who saw some of my early Castlevania Symphony of the Night developers diaries, you've noticed that there was a bit of a wall jumping problem, where if Alucard got too close to the wall, when you jumped, it kind of gets stuck on the wall and you can keep jumping up and up and up, and that's the problem here. Thankfully the solution's pretty easy. We just have to go back to our if player move right if statement, and within that tile collision if statement, within that we simply take the player X and we minus 0.1 from it, and that just moves it enough away from the wall that we won't get stuck on the right hand side of the wall, and the little bug that we experienced before will no longer occur. So now the character's sliding in between the little gaps as we wanted, and if we go to the right hand side wall, we can see I can hold right and go up and down, and thankfully it's no longer catching on that any kind of right hand surface. And as for the left hand side, we don't have that issue anyway, so nothing's required. But of course now we have to finish off by doing the bottom collision, the collision at the bottom of our little collision box. Since you've already been through this 3 times before now, I'll just show you what the completed code for the down movement should look like. And if we load it up onto the ROM, we still have a bit of a problem where it gets stuck on the bottom if we hold down and move left and right. Just the same problem we had previously with when we hold right and try to move up and down. Now what we need to do now, we need to do player Y and just minus 0.1, and then that will work. If we now save and compile, everything should be working fine. So again, at the very top we can squeeze into these little gaps without getting caught, and with the table too I can keep holding down and left and right and to the bottom as well, and nothing gets caught or snagged. I'm just moving all into these small little spaces, and again the code seems pretty robust that we've written. It's all very smooth. We did go through a lot today, so I'm just going to take you very quickly through the code. So this is the resources.res folder, nothing special in there. It's in the main.c where we did all our work. So first of all, remember we had the actual collision array itself here and how it's defined, what we created using 16 tile. I did the length of the array, and then we did the solid tile, we defined that as 1. And then if we go down here, this is all pretty much the same. We didn't change the camera stuff. What we did do is we created the offset for the collision box in comparison to where our sprite was located, and then of course we had to create these booleans for moving up, down, left or right. And then after that we go down, we have our little collision, we call it collision code in the middle here. And of course we also had to define that up here. We had to do the prototype here, so that then we wrote the actual code at the bottom just so you knew that, you know, this one existed, it didn't do any errors. And then we have in our handle input, we had to change these so that it activates the booleans, the true or false for move up, down, left and right, rather than doing the actual movement. In the camera, we didn't make any changes to the camera function, and of course it's in the collision function where we did most of our work. So remember, the whole point of all these calculations and variables was to work out whether the various corners of the collision box, whether they fell into a solid tile or a free tile that we could walk through. And then in order to do that, we created the first we calculated what the where the collision box was in terms of the left, right, top and bottom sides of the collision box, where they were in terms of pixels on the screen. And then we had to find out where they were in terms of the tiles on the screen, the 16 by 16 tiles, or you could think of this as the row and the column numbers beginning from 0 of our collision grid. Once we had those values calculated, we could use that information to calculate where on our collision grid the top left, top right, bottom left, bottom right corners of the collision box we're falling into. So remember, with our collision array, they have an index, so it begins with 0, 1, 2, 3 all the way up to 280, and we had to work out what was the particular index from 0 to 279 each of the corners of the collision box was falling into. And once we had that information, we could then use the index to see whether that particular part of the collision grid was a 0 or a 1, and we could then use that to determine whether the player can move or not. And if it was a 1, a solid tile, then we use the block chord, the calculation, to see where the player could move into. And finally we had all these if and if else statements for moving left, right, up and down. And that's when we really actually moved the player, and we either moved them to where they were if it was a free tile, or if it was a block tile, then we moved them right to the very edge of the solid tile that they couldn't move through. I'll carry on going through the code very slowly just so you can check if there's any typos in your code, if anything went wrong anywhere, and you can correct it. As a special thank you for Patreon supporters, I will be supplying the source code for this tutorial and all future tutorials as well. Up until now, there's been no special benefit from being a Patreon supporter, so I've been thinking of ways that I can give something extra to say thank you without taking away from the regular YouTube channel, and a few people have been asking for this, so I thought it would be a good idea. However, even for those Patreon supporters, I would still highly recommend that you follow the video and type it out bit by bit manually rather than copying and pasting from the source code, because that way you really learn how it works. If you copy and paste, it's a bit of a shortcut, but I think in the long term it's not really great for your learning. In the next lesson, we will turn this top-down game into a regular 2D platformer with our gravity and jumping, and thankfully, because we've got such a good foundation here, the tutorial won't be as long as this one has been. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.